Good morning once again. Yes. Today we'll be looking at identification of anions. Identification of anions. So just grab your seats, and at the end we are going to agree with me how simple it is to identify anions in the practical session. Now, the anions that we are normally required to identify are, we have SO4 2 minus, that's the sulfate ion. SO3 2 minus, the sulfite ion. Then trioxocarbonate 4 ion, as well as trioxonitrate 5 ion, sulfide ion. Then the halogens, chlorine, bromine, iodine. These are, yes. Unlike the cations, we don't have two specific reagents for identifying them. You don't have two specific reagents for identifying them. So come along, let's see how it is done. Okay, so as usual, it's a 3-column activity. There is a test. There's observation. And there is inference. There is a test, there is an observation, and there is inference. Now, to start with, let's start with the sulfate ion. This is what happens. SO4 2 minus, barium chloride is added to SO4 2 minus, followed by dilute HNO3. And this is the expected observation. You're going to have quite chalky precipitates. But at this juncture, you are going to suspect 3 anions. You're going to suspect SO4 2 minus, SO3 2 minus, as well as CO3 2 minus. So as a matter of fact, it is the addition of the HNO3 that will enable us to conclude that it is SO4 2 minus. Now, when the HNO3 is added, the precipitate is insoluble, implying that SO4 2 minus is present. So the addition of the HNO3 will make the solution insoluble, implying that SO4 2 minus is present. Now, okay, so let's look at how SO3 2 minus will behave. So similarly, so with the SO3 2 minus, the same procedure. SO3 2 minus, we add barium chloride equals barium chloride, followed by HNO3. Now, Similarly, it produces white, chalky precipitates. But at this time around, when the HNO3 is added, it becomes soluble. So that is how we are able to distinguish between SO4 2 minus as well as SO3 2 minus. So the precipitate is soluble. So when it's white chalk precipitate, as usual, we suspect SO4 2 minus, SO3 2 minus, as well as CO3 2 minus, suspected. But it is when we add the dilute HNO3 that we will be very sure that it is SO3 2 minus present. Okay. Now, in this category, we move on to the CO3 2 minus as well. CO3 2 minus is a triisobicarbonate, and as it is in chemistry, when an acid is added to a triisobicarbonate, we produce carbon 4 oxide or carbon dioxide. So it helps us to identify the carbonate. So here, CO3 2 minus plus HNO3, see, there will be an effervescence reaction with the evolution of carbon dioxide. So what we write here is effervescence occurs. To stop. Colorless and odorless gas evolves, which turns lime water milky. Obviously, this is carbon dioxide gas. So we conclude safely that gas is CO2, therefore CO3 2 minus present. So a quick recap. SO4 2 minus, we add barium chloride followed by HNO3. And you're going to observe a white chalky precipitate. And at this juncture, we are required to suspect SO4 2 minus, SO3 2 minus, as well as CO3 2 minus. The precipitate will be insoluble, implying that it's SO4 2 minus present. When we come to the SO3, similarly, but then the precipitate will be soluble. Then when we come to the triisocarbonates, we add the HNO3, then know what effervescence reaction with the evolution of a colorless odorless gas, returns lime water milky. So this is how we test these three anions. To identify the trioxynitrate 5 ion, this is the test. We add freshly prepared FeSO4, that is iron 2 sulfate, followed by concentrated H2SO4. Now let me emphasize, the FeSO4 must be freshly prepared, because if it's allowed to stand, there will be aerial oxidation, so it must be freshly prepared. And when this is done, you're going to observe a brown ring. A brown ring is formed in the middle of the solution. This implies NO3 minus present. Now, this is called the brown ring test. So anytime you hear about the brown ring test, it involves adding freshly prepared FeSO4 followed by Conc into SO4. Now we move on to the sulfide ion. In the sulfide ion, we add dilute HCl solution and warm. By so doing, the gas that evolves has a very offensive smell. It smells like rotten egg. So a gas evolves which smells like rotten egg. Then it implies that S2 minus is present. S2 minus is present. Then lastly, let's look at how chlorine is identified. Chlorine is a halogen. This is how it is identified. So chlorine, the chlorine ion, you are required to add dilute HNO3 solution followed by silver nitrate, that's AgNO3, and then excess ammonia solution. And then excess ammonia solution. You are going to obtain, when you add the dilute HNO3, you are not going to observe any precipitate. So there will be no precipitate. But when we add the AgNO3, there will be a white precipitate, implying chloride ions are present. Then when the excess ammonia is added, you're going to obtain, it's going to dissolve. So precipitate dissolves, implying chloride ion present. So that will be the end of the identification of the anions. And I know it's going to be enjoyable. I know you've learned a lot today. So watch out for my next episode. Thank you very much and have a nice day.